Okay, today I'm going to show you how to replace a burnt trace on an Atari edge connector. Much like the one you see here. This is an old Atari pole position board, and as you can see, one of the pins got pretty fried on the edge connector. It looks like somebody came in and did a real quick repair. But what we want to do is replace that this ugly field repair with something that looks a little bit more like the original. Now, what happens a lot of times with these Atari boards is that the crimp terminals and the crimp housings on the wiring harness, these crimps have a dissimilar metal than what's on the edge connector pin. Anytime you have two dissimilar metals in electrical contact, over a number of years they'll start to develop a corrosive layer between them. This corrosive layer gives some added unwanted resistance. And what you basically end up with is a voltage divider. You have resistance coming across on your pin, and you also have resistance of your load, which is the circuit on the card. Now, ideally, what you want to have is no resistance coming across your pin. What that allows is the full voltage from your power supply to appear at the input of your card. What happens with the corrosive layer that builds up? It increases this resistance, and as that resistance increases, you get a voltage drop across it. Say, for example, we might get 0.8 volts worth of voltage loss on that pin. Well, since this is a voltage divider, it brings down the voltage on your card by 0.8. What the power supply does is it senses this voltage and it kicks up the voltage that it puts out to compensate for the voltage loss across your pin. What this means is you get some unwanted power dissipation across that pin. As your resistance increases, so does your power dissipation, and with that power dissipation comes heat. And after this pin connection gets corroded and gets really bad, and the resistance increases, you get more and more heat building up, and that's what fries the pin on the board. Now, to do the repair, we need a few items. We need an X-Acto knife, some cellophane packing tape. Also, this stuff is great because the epoxy that we're going to use on the to repair the substrate won't stick to the tape, and so you can use this tape to mask off any areas that you don't want epoxy to be. Also, cut up some little pieces of cardboard. Make 4 of them, and then cover 2 with your cellophane tape. We're going to use these guys to hold down your pin while it dries. Epoxy. I use 3M Scotch Weld. It's okay stuff. I like how it dries. Makes it real easy to sand this stuff down, although the only drawback of this stuff is it takes several days to cure. Now, the epoxy is going to dry clear, so what we want to do is put mix some sort of colorant in there with it, so that the epoxy better matches the color of the substrate. And what I found works really well is just some regular old Testor's enamel paint in different colors. You mix it up, try to get the color as close as possible, and you mix a little dab of this stuff in with your epoxy, and it turns out real nice. Now when we want to hold the pin down, I'm going to use a small hobby spring clamp. You can find these at hobby stores, maybe some hardware stores. I found this one at a local hobby store. I got like 8 for $5. It was a pretty good deal. After the epoxy dries, you're going to want to sand it down. So I've got some 220 sandpaper that we can use. You're going to want some solder wick. And last but not least, you're going to need to have some copper tape. The copper tape that I use has is plated with tin, and the tin better matches the original trace that's on the edge connector. The copper tape you can find at Mouser. It comes in a 3/4 inch by 18-yard roll, which is a lot. It's much more than what you need for a single repair. So it really is kind of a lifetime buy. You buy the roll once, and you know, you've got enough to last you forever. The manufacturer is 3M. Here's the part number for 3M. If you order directly from Mouser, here's the part number to order from Mouser. Okay, I think we're just about ready to begin. Our first step is to remove the old work. Just going to dab a little bit of flux onto the joint here. Then take your solder wick and your soldering iron and just go to town here. There we go. We'll flip it around and do the back side. Oh, this is funny. It looks like somebody used solder wick as a shunt. That's interesting. Alright, let's get the rest of the solder up here. Hey. Oh, thank you. You're very sweet. Thank you. Okay. My daughter just made me a little snack. Alright, looks pretty good.